Good morning. I'm a little bit trashed today, but hopefully we can get some things done. I was out on a date last night, and it got pretty late. Haven't slept a lot really, but let's continue on our TAC compiler. It must be part 5 now, I think. I'm just gonna have some Swedish candy. Okay, so basically the problem I had last time we were working on this was like we have no idea to locate variables like this right now. So we were trying to access argv1, but we don't know how to look up argv yet. We don't know what argv is. So we need to take care of this, and I've been thinking about it a little bit. And I think I have an idea of how to do this. So first of all, I'm gonna have to change all of these method signatures and add a couple of arguments. So actually what I'm adding here now is not actually it's not really necessarily representing these arguments here. I'm just gonna call them the same because basically we're gonna have all of these because all of these methods here are recursively visiting the AST, the abstract syntax tree. So what we can do too, our problem is that when we're encountering a token or an identifier, we don't know where it comes from. We don't have any context. So we're gonna give our visitor, because this is like a visitor, it visits each node. So let's just call it a visitor, but we're going to add some context. So what we're going to do is we're actually going to do int argc char, no, astt argv. I wonder, I think we should do that maybe. And then we can push. No, actually, let's do, maybe we should have a list instead. So we would have a, wait a minute. So we could actually just use a list t, or do I want to do that? I don't know. I don't know. Let's just use a list actually. So we're not gonna use the argc thing. We're gonna use a list, and we're actually going to put it here as well. And then we're just going to do the labor work of adding these to all the signatures. It's probably a cool vim command to do that automatically, but I don't know it. So basically this list is like a context type of thing, where we can store a context of like where things are coming from, sort of. So, okay, now we also need to add them here. And then we need to add it here as well. I'm adding it to all of the methods, even though it's not being used everywhere, just to in case we want to use it later. So now we need to pass it down here as well. Okay. I might regret using that list type later, we'll see. And now when we're doing this root thing here, we're going to do a it's not really happy. Why are you not happy? Now it's happy. Okay, so are we still able to run this? So tech examples main.tech. Yeah, cool. So it still works. Let's just have some coffee. So that still works. So basically this list here will act like a virtual stack, sort of, so that we can keep track of things. So where am I going to use this now? So basically, whenever we push arguments to the stack here, we also want to keep track of them here. I think. No, no, actually not. When we're encountering a function, we want to read the arguments, and we want to push them into the list, this list here. So the way we would do that is basically let's just see if we have some arguments here. Asked children size. I think they will be in there, and it needs to be no. Asked val. Oh, it's because sorry, should be in asked val as well. So we have two arguments, and that is correct. This function has two arguments. So now we need to like push them into this list. So what we're going to do is for sign if I equal to 0, I is less than I plus plus. And then we're going to actually define these variables. We're going to create new AST, so we're going to do ASTT arg variable is equal to init ast variable Okay. And the value of this variable, or wait, arg variable name is going to be, let's do this as called farg or something. Children items I. So the name is going to be a farg name. Okay. So we don't really know, like the value of this thing is actually just going to be a integer. Just going to be a integer. So arg variable int value is equal to I. And then we need to push this into the list, so we're going to do, okay, so this might be, I think we should create a new list here because we don't want to, I'm not so sure we want to keep pushing it, or maybe we want to do that. Maybe we want to do that. It's possible that we actually want to, maybe we don't want to create a new list. So let's just not create a new list for now. So list push, we want to push into this list, and we want to push the arg variable. So let's see if it's happy. It's happy and it works. It doesn't do anything weird. Let's just see how many times we're pushing this. Good, we're doing it twice. That's perfect. So now what we can do is when we're now we're going to encounter, now we're going to visit the body, and the body will be given the list. Cool. And the body is going to be a compound, so it's going to pass in that list to each child. And once we visit this call, we actually want to do a lookup inside of this thing here to see if we know what this symbol is. So I think what we want to do is what exactly do we want to do? We want to drink some coffee, that's for sure. I think we're going to define a method that gives us actually this value here is wrong, I think. I think we should add as well children size plus. I think that's what we want to do. And then we want to do a lookup for this here. Want to do a lookup. So let's just do a ASTT static ASTT bar lookup, and it's going to take a const char name, and it's going to wait. Let's do this. Where do you want to look? We want to look in this list, and we need to specify a name. And then we're going to do this thing again. Except for and then we're going to do a and we also want to make sure here that if not child asked, equal to asked. Continue. Or if child asked. No, child asked. Or if child asked name, or if not child asked name. Return 0. So now what we can do is now what we can do is we're going to remove a argument here from the variable thing. We're not going to use this. No, let's just do 0 for now. And then when we also need to remove it here, of course. And then when we I lost my track of thought. We're going to do that. I think that's it. And then when we encounter the variable here, we're going to do a lookup. Wait, will it ever be an int? That's never going to happen. Okay, so now we need to do a lookup. So we're going to do STT var is equal to var lookup list name, and then we're going to use var int value, but first we're going to do if not var printf is not defined. Are you happy? You're happy. And that one is happy as well. Okay. So what if we just return argv now? What's going to happen? Actually, let's do this first, because what is happening here? What's going to happen here? I just want to go through it. So we're going to reach the call, and you're going to do a lookup for that variable. You're going to do a lookup for that variable. Or you're going to do a lookup for where. Yeah, you're doing a lookup for the variable. So you're going to do a lookup for the variable, and it's going to give you the index, or it's going to have the int value of the index in the function signature. Which is all right. It's all right. I think that's all right, actually. So what do you look like right now? You're moving 2 into SP. Oh, that's correct. You're moving 2. Wait, what? So it didn't work. Didn't work. Oh. Is it because we need to do times 2? Is that it? I don't know. For so that seems to be correct. I wonder what's going to happen now if we do a argv. Doing a 10, that's wrong, isn't it? 4 times plus I times 4 that seems to be correct. How does that really work though? Like, why are we getting 4? 12 should... No, wait. Let's just hard code. Let's just hard code. Let's hard code 4. I think 4 is actually, because we're doing backwards, right? So I think 4 is actually the next value, isn't it? Because we're doing backwards. Which gives us a 12. Okay. So what we really want to do is actually, so we have these many bytes, and then we want to remove I times 2. what do we get if we do that? We're getting 8. Cool. And then we want to remove we're getting 6. Oh, we want to remove 4, sorry. And now if we do argc, we should get the 8 again. Yeah, good. Good. Okay, so now if we do argc now, we should still, no? Oh. We're getting that, good. So now what if we did argv 1? You're moving 0 into there. And why are you doing that? Because we have this axis thing. So we're ending up here, right? No? Oh, I know why. Let's do it this way instead. Now we're ending up there, but we're getting some problems here because we're putting nothing in there. But if we do this again, it should compile. Yeah, good. And if we do this, it should compile. Yes. It just gets confused when we're trying to do that, which is understandable. Because now we're in the axis here and we're not returning anything interesting. So what we need to do here is first we need to look up that variable again. So we need to call ct left is equal to var lookup name. Just print that. Cool, we're getting it. So now it just doesn't know. Now we don't know. Do we have an int value here? Zero. Is that really what we're doing? Yeah, we're doing 0. What if we do 1? So that's not what I wanted. Oh wait, I know why. It's actually going to be in No. Now we're getting the 1. Okay, good. Good. Const char left pointer is equal to is f left. Okay, if we return left now, we're getting something weird. Oh. No, wait. We need to do char left s is equal to is f left. Now we're getting the 4, which is expected. It's expected, but we need to. I think we need to move this into like a separate thing. Oh, let's see here. Okay. So in this case, we want to think we would have to do something like this. And then we would have to do so in this case, 0 here will be the first string in that argument list, I think. $131. Okay. And if we move 4, I think that should be, where is it? Because we don't know the size of these things. We don't know where, maybe we do, because these are pointers, I think. So if we do 4, we're getting something else. I would have expected something else. But I think that's like a pointer, just like an address or something. But I think this is kind of what we want to do. Now I just don't know how we're going to implement that. So, main. We want to move this thing into EX, ECX. And then we want to do return ECX, I think. junk. Right. We're getting a move twice. Because I mean, this is basically what we want to do here. The problem is that we haven't pushed anything into ECX yet. So I mean, this should be ×4. Because we're accessing 1. But we also need to push into so if we put this back and we do because we already have a move into ESP there. And why do we move? Oh wait, what if we move this into EX? So we do a EX. Which means that we will be moving this into EX. And then we need to add a other move into EX again, or move from EX, I mean. So we're moving this one into EX, then we're doing that into EX. I think that works. So if we do 0, we should get something else. Yeah. So I don't know if this is correct actually. We can't see what's in that argv value right now because we don't have a way to print strings yet. But what we have implemented now is a generic way to access the locations of the arguments for a function, and hopefully we have also managed to access the pointers inside of this argv here. Now, as I said before, we can't test if it actually works correctly right now because we don't have a way to print it. So hopefully in the next video we'll implement a print method as well that will help us debug these things. And then we would just write that value into stdout to see it in the terminal. So basically we'll do that in the next video, okay? But yeah, we've gotten pretty far now. It's very cool that we can access these values. But thank you for watching, and I'll see you in the next one.